Advanced Algebra 2, Quadratic Inequalities, Concept 12.5. So first we're going to start solving inequalities that are in two variables. And by solving, what we're going to do is graph them on a graph space and then show the shaded region which describes the inequality. So the first thing you want to do with the quadratic inequality is graph the parabola as if it were an equation in standard form. If the quadratic inequality is less than or greater than, you will use a dashed curve for your parabola. And if it has an equal to mark, then you will use a solid curve. The second step is to test a point inside or outside the parabola to determine which of those areas will have the points that will satisfy the inequality. There are just some general rules that we can follow, but testing a point is the most accurate. And then that will determine where you want to shade. So either inside the parabola or outside the parabola, above or below, to show the region which satisfies the inequality. Step 3, you're going to shade the region if the point is a solution from step 2, and you're going to shade the region on the other side of the parabola if it is not a solution. So this will make a lot more sense once we graph. So let's start in example 1 with this inequality. Y is less than the curve negative x squared minus 2x minus 1. So the first thing we want to do is think of that in terms of an equation and graph it. So you know how to do that. You're going to find the vertex. So our x value will be negative 1, and then if we plug that in, our y value is 0. Put it in the middle of your table, and then fill in x values in the left and the right direction. Find your y values. Now draw your xy axis and label a scale. So I noticed that my inequality is less than, and so that means when I plot my points and then draw my curve, I'm going to have a dashed line because y is not less than or equal to, it's just less than. So it's not equal to the actual curve. So I'm going to plot my points from my table, and then I'm going to draw a smooth dashed curve through my points. I'm going to extend the curve all the way through my graph space. I go back to my inequality and notice that it is less than. So a general rule is that I can shade, since my parabola is pointing downward, everything that is underneath my parabola. I'm going to test a point outside the parabola just to make sure that I have shaded on the correct side of the parabola, and in this case it's on the inside. So I picked the point 0, 0 because it's very easy to plug in. It also is outside my shaded region right now, so it should not satisfy the inequality. It should not be a solution. So 0 for x and 0 for y, I plug it into my inequality, and I get 0 is less than negative 0 minus 1, or 0 is less than negative 1. That is not a true statement, so that means that point is not a part of the solution area and shouldn't be shaded. So my shading is correct. So all the points that are underneath that parabola and below, if I picked out any xy pair and plugged it into my inequality, it would make a true statement. So that's how you quote-unquote solve just inequalities in two variables. You graph them, and then you shade the region that satisfies the inequality that makes it true. Example 2. So here's a real-life situation. So a manila rope is used for rappelling down a cliff, and it can safely support a weight, W in pounds, provided weight is less than or equal to 1,480 d squared, where d is the diameter in inches of the rope. Graph the inequality and interpret the solution. So my input will be d, diameter, and my output is weight. I'm going to plug in values for the diameter rope that makes sense. Now I'm going to start with 0 and just work from there. So I've decided to go in half-inch increments. So I plug in a half, and that can support a weight of 370 pounds, 1 inch. Plug it into my, and I'm treating it like an equation. So W equals 1480 d squared. An inch will support, obviously, 1,480 pounds, inch and a half, 3,330, and 2 inches, 5,920. That's some pretty thick rope. Now to graph the inequality, I notice that I don't have any negative values, so I'm going to use an L-shaped graph just to utilize my space. My X, or in this case my D axis, I'm going by 1/10, and so every fifth mark is 5/10, and then I decide that every fifth mark will be 1,500, or every single mark will be 300 pounds, and that takes me all the way across the graph space up to 6,000, which is just above the highest weight that I need to graph. So now I'm going to plot these points. I'm going to label my graph. So my x-axis or input is diameter in inches, and my y-axis or output is weight in pounds. So graph the points 0, 0, 1/2, 370. Now I noticed that my inequality is the weight that is less than or equal to. It's equal to, so I drew a solid curve through those points. And then I want to show everything that is less than that weight. So I'm going to shade below. So in the shaded region, that shows all the different combination of ropes, widths, and the amount of weight that the rope could support. The region that is not shaded, that is above the curve, would be diameters of rope, and then the weights that would not be supported. So the shaded area represent ropes of different diameters and the weights that can be supported. Example 3. Sometimes we'll have a system of quadratic inequalities. That's two graphed on the same space. So we're going to start with y is less than negative x squared plus 3, and y is greater than or equal to x squared plus 2x minus 3. So we're going to treat the first one as an equation, and we're going to graph it. So we'll start by finding the vertex. So x will equal 0, and then plugging that in, y is 3. So we'll put that in the middle of our table, and then put in x values around it. Our y values will be negative 1, 2, 3, 2, and negative 1. Now I'm going to move over and get my table of values set for my other quadratic. So finding the vertex is where x equals negative 1 and y equals, plugging that in, negative 4. So that's my vertex. And then I'm going to find x values around that. Now when I go to graph, so moving over to the quadratic on the left again, I notice that its y is just less than negative x squared plus 3. So that means I'm going to use a dashed curve. So I'm going to plot those points in blue after I draw my xy axis and label a scale. So I'm drawing my curve in blue, and I'm covering my graph space. So I'm going to extend all the way down to the bottom of the graph space. That just helps with the shading. Now going over to the quadratic in green, I notice that it's greater than or equal to. So I'm going to draw, after I plot the points, a solid curve and extend that. Now I'm going to shade the area that satisfies both of these. So my first quadratic in blue, it's less than. So it's going to be everything that's below or kind of underneath that. My second one in green is greater than, so it's everything that's above. So there's my area below and above. So I'm going to shade that in yellow. So I am shading just the area that satisfies both inequalities. Here's another example of a system of inequalities that's already graphed. I'm just going to highlight some of the aspects of this. So this is an example of a system of inequalities. So that means two inequalities, and they're quadratic, so I have two parabolas that are graphed. So one of them, its y is greater than, so that's the one with the dashed curve. And then one is y is less than or equal to, so that is the parabola with the solid curve. So notice there's a shaded region. The shaded area is actually the area that both the graphs have in common. So our first graph, y is greater than x squared minus 4, graph number 1 in red, and that's the graph of it. So since it's greater than, we're going to shade above the curve, and it'll end up being inside. And then the second graph is y is less than or equal to that parabola. And so notice it's less than or equal to, so we need to shade below. And then the common area is that little oblong, almost an oval shape there that is shading above the first parabola, but then also below the second one. So we're going to shade the area that is in common.